starting to figure out how can they use machine learning and related techniques for their bioinformatics research. And so what this webinar will do, it's just to set expectations. It's not really anything about machine learning theory. So I'm not going to cover any, particular real world use cases or talk about, what the best model architectures might be for this or that use case. Instead, I'm going to show essentially how you can support machine learning workflows on Terra, and what are some of the services and tools that can help you do that. And so most of the examples that we'll look at come from this example workspace that Liz just pointed you to. And there is a related set of solutions articles on some of the stuff that I'm going to talk about. And there's also a GitHub repo where the example notebooks that are used by the workspace live. And so that's particularly if you find any issues, or have any really specific questions with the notebook examples, you could file an issue with the GitHub repo as well, and that would be helpful. So here is, let me just skip ahead for a second. Here's the agenda for what we're going to look at. First, how to do in notebook model training in a Terra workspace. And you'll see what I mean by that in just a moment. And then look at a variant of that where you're training a model in your notebook, and you want to also improve the accuracy of the model by using something called hyperparameter tuning. And then we'll sort of switch gears a little and say, what if you instead wanted to use some of the Google Cloud Platform Vertex AI services and tools, and we'll start to dig in a little about what some of those useful services might be, and how you can access them right from the Terra notebook without leaving the notebook. So we'll talk about training and serving models on Vertex AI. Then look at something very interesting called BigQuery ML, which, if you're not aware of it, lets you automatically train models from your BigQuery datasets. And if time permitting, I'll also show you a little bit about Vertex AI pipelines and how that can help you. We'll see if we have time for that. So one thing that unsurprisingly I'm going to do, just due to time constraints, is what sometimes you hear called the Julia Child method of giving presentations, or the cooking show method of giving presentations, where I'm going to kick something off and then skip ahead to the result of seeing it run. So just be aware that when you work through, if you work through these examples yourself later, they will take longer to actually run when you run them yourself. And some of the more complex examples, especially the ones that access Vertex AI services, depending on how long they run, they might, the cost of using that service might sneak up on you. So be sure to pay attention to the estimated costs in the notebooks. And so overall, with these examples, again, given the time constraints, you don't worry about sort of grasping every single detail, particularly about how to make some of the API calls and things like that. That's the goal of this webinar, is to give you a high level sense of what are the approaches and services that might be useful to you, and sort of equip you to dig into them more as you want to. So you can always come back to the notebooks for the details. Just for this webinar, don't worry if you're not catching every single detail. Okay. And so a couple more things to mention before I start to get into the nuts and bolts of things. So as I go through the examples, I think what I'll do is I'll pause after each one and see if anyone has any questions rather than batching up all the questions for the end. So we'll kind of alternate a little bit of a discussion section with the examples. And if you're going to work through the examples later and you have issues or want to give feedback on the examples, you can either email me, and so I've got my email address here. And you can also, please do file issues in the GitHub repo if you see something that's broken. Okay. And then the other thing that I wanted to just give a little bit of a heads up on at first is that, so I mentioned that for some of the examples that use Vertex AI, the so-called native GCP count is also required. And that link, if you click on it, goes to this page that tells you all about that and how to set up this so-called native GCP account. So, you know, if you don't already have one set up, there won't be time to do it now, but this walks you through the process very carefully. And if you have questions afterwards, please do contact us. Okay. All right, so jumping in. The first thing that we'll look at is kind of the most straightforward and what you probably will just start with and maybe finish with in terms of your research much of the time. And that is just simply doing in-notebook model training. And so this is the notebook that we're going to look at first, if you've cloned the workspace. And of course, all my links are to the original. So be sure to bring up, if you're going to run anything, be sure to bring it up in your cloned version. So what I have for running these examples is my own cloned version of this workspace. And I'm going to start with this notebook. And let me take a little bit of a poll. Maybe Liz, you can tell me the results of the poll. Do you prefer this font size or this larger font size?
I think the larger font size seems to be the preference.
I think it's winning. Yes, I can see the comments come by. Okay, very good. Okay. So before I start running this notebook, so I've already set up the cloud environment for it. And let me just show you how that is configured, because it's an important aspect of running this notebook successfully. And the introduction has this information. I'm using a non-standard configuration for this notebook. In particular, I've created it to use 4 CPUs. I think the intro blurb says you can probably get away with 2, which I think is the case, but it kind of runs more smoothly with 4. So 4 CPUs, and I've clicked enable GPUs, and I'm using currently one T4. And if you opt to use more GPUs, like say I changed it to 2, the example would still run successfully, and in fact would run quicker. And so it adapts to the number of GPUs that you're using. And of course, it also would be more expensive to run, per minute. And another thing that I did was so you might want to pay attention to this auto pause option and disable it entirely, perhaps, although that can be dangerous because you can inadvertently, you can forget that your notebook is running, and then that incurs charges. But you might want to bump the default number of minutes of activity before the VM pauses, because when you're running a notebook, running model training in a notebook, of course, it can sometimes take a while. Okay. So this particular cloud environment, as you can see, is costing me 57 cents an hour. All right, so let's get started. So this is an example that is using TensorFlow, more specifically Keras, to define a machine learning model. And the use case is doing learning to classify tissue sample images. This is a data set that's part of the TensorFlow dataset hub, so it's really easy to grab for an example. And what we're going to do, these images are labeled, it's a binary classification problem. The images are labeled with indication of whether metastatic tissue is present or not. And so we're going to learn to detect that in the model that we're building. So the specifics of the model are not important, although I'll point out the model that we're using. But again, this is just kind of an example to show some general principles. There's nothing that says you have to use TensorFlow, of course. If you're a PyTorch fan, that will actually work just as well, sort of the whole way through this set of examples. But here we're using TensorFlow just for convenience. So I'm going to do some imports. Now I'm going to do something that is a useful trick. I'm going to automatically grab the workspace bucket that is associated with this workspace that I've created. So yours will be different, of course. And then I'm creating a timestamp, just because you do multiple runs. This helps you discriminate between them. Okay, and now I'm going to do something that if you're playing along, actually will kind of hang you up, because this actually takes a while the first time you do it. Is I'm going to download the data set from the that I'm going to be using from the TensorFlow data hub. And so we'll download it to the persistent disk, and that only needs to be done once per persistent disk. I've done this already, and so it's finished for me. If you're running it yourself, it's a 7 gig data set, and will take a while. And incidentally, if everyone is trying to do this at once, there might even be some access problems. So if you have problems, try again later. But now that I've got this data set loaded, it's on my persistent disk, and as long as I maintain this persistent disk, I never have to do this again. Okay. And incidentally, this shows an advantage, of course, of working in the cloud. That that's a pretty large data set, 7 gigs. But of course, that's not you're not worried about your local bandwidth, because all this is happening over the cloud network. Okay. So I've loaded my data set. I can print some information about it. This is not particularly important in the more general case. Now I'm going to create from the data. I'm going to create the different data sets that I'm going to use, train, test, and validation. I'm leveraging something that's TensorFlow specific. They have a whole module for dealing with and pipelining data, and any of the other frameworks would have the same, like PyTorch would have an inlog to that. Okay, we'll view a few of the images just to kind of sanity check. Okay, and now we're going to define the Keras model, and just to keep things simple, we're going to use a pre-built model exception, which is often a good choice. It's a convolutional neural net that's often a good choice for image classification types of problems. And I see some comments coming in, which I'll look at in a second when I finished kicking this off. And so one interesting thing to notice, just as a general technique here, is that I'm actually using transfer learning, which is really useful for being able to bootstrap, training on your own data. I'm loading some weights, some model weights that have already been trained on ImageNet data. If you're familiar, it's just a bunch of large number of relatively small res images that have large number of classes that they're trained against. So by doing transfer learning, I'm essentially building, adding some additional layers to that model and its learned weights. And for the transfer learning stage of what I'm going to do, we're freezing the base weights. So those weights don't change during training, and we're going to train the new layers that we've essentially added on top of it. Okay, so here I'm defining the model. Here I'm using a feature that, again, will be available in all machine learning platforms. Is with TensorFlow, it's called mirrored strategy. If you have multiple, if you're running multiple GPUs on the same node, on the same VM, you can do in-node distributed training, which TensorFlow calls mirrored strategy, in order to leverage more than one GPUs on the same node during your training job. And so the specifics of this will vary depending on what machine learning framework you're using, but in general, keep this in mind as a good strategy for in-notebook training. You can boost up the number of GPUs that you're using. You'll want to commensurately boost the number of CPUs, and then do within node distributed training to really speed up your job. In this case, however, I'm only using one GPU. Okay. Can print out some information about the model, define some callbacks, and we won't go into the details of that. This is doing some logging that will be useful to us, and then kick off the model training. So this is the transfer learning phase, and for this example, we're going to do it, say, for 4 epochs. Okay. Wait till this gets started. You can see it finding the GPU, and you would get a different kind of error if it couldn't grab it successfully. Okay, and we're off to the races with the training. And while I'm not going to wait for this to finish, let me show you one more thing. If we had time for those first 4 epochs to finish running, the transfer learning, then what we would do next is another stage of model training. And so this is just a useful general approach. It often helps to do what's called fine tuning, different from transfer learning, where once we've done some initial transfer learning, we unfreeze the rest of the model weights, the weights for the entire model, which is what's going on here, and then do some additional training. So now we're able to update all of the model weights, not just the new transfer learning layers. And if we do that, the accuracy increases very, very significantly. So this is an example where it actually helps to, even though we're kind of bootstrapping with transfer learning, it actually helps to do these 2 stages, transfer learning and then fine tuning. Okay. So I'm going to interrupt training job, and then so that this error is just due to the interrupt. in true Julia Child fashion. I'm going to skip down to how you can save your trained model and reconstitute it, use it for prediction later. And this is really important when you're doing this kind of prototyping and model training, right? Because if your notebook kernel idles out, or something happens, you're going to lose all your context. And so you want to first of all be regularly checkpointing during model training, and in case that happens. And then when you get your trained model to a state where you want to save it, then and again, the details will vary according to platform, but you can always do something like this. So you can in Keras, we can just do model.save and give it a path, and you can for that path, you can construct a Google Cloud Storage or GCS path as well. And your workspace always has a GCS bucket associated with it. So at the beginning of this notebook, we went and found that bucket name. And so you can always use that bucket to save your trained models, or they might be in an intermediate state, but you can always save them off to GCS, and that's a really useful trick to do. So here we're doing it with Keras, saving our trained model, and then later you can load and use the saved model just by providing a local file system path or a path in your GCS bucket. So that's what I'm about to do here, and it actually it's a large model, in fact, with many variables, and so it's actually going to take just a little bit of time to reconstitute here. Let me check the chat questions while it's running.
We did have one question, Amy.
Okay.
It asked, are there no ways to access these types of common files without recopying to disk, e.g. access the data set in an open bucket?
Yeah, if I understand your question correctly, the answer is yes, you can always do that. Just for, we sort of, for this workspace, there are extra complications to to download a copy of the data set and sort of preserve it as part of the workspace. So we didn't do that, but in general you certainly could. And the labels list, and yeah, there's a question about the labels list. The labels list is actually in this context is the field in the training data, which indicates whether the tissue sample is metastic or non-metastic, and that was a column in our training data. And so so now that we're using the trained model for prediction, we'll use a different withheld data set that wasn't included in training, and we'll use what's going on is we'll use the answer, essentially, what's the label to see if prediction got it right. So that's the labels in that context. Hopefully that answered your question. Okay, and the model is still reinstantiating. It's a little quicker if you do it from local storage rather than GCS, but essentially it's just because the model is so large. One more minute. Okay, keeping an eye on the time. I may skip this and move on to the next notebook, but essentially what's being shown here is what, once you have your model, whether you loaded it from from some saved files or it's just in memory in the notebook, you can, and again, this is, Keras code, you can use it to send data to and get predictions. And so that is what's being shown here. Probably is not worth going into the details, but if you're familiar with how you would use a machine learning model to make predictions, this is exactly what you would imagine. We're getting predictions are for each class, 0 and 1. 0 is non-metastic, 1 is metastic. We're getting these probabilities, and so essentially the largest number wins, and that is our prediction for that image that we fed to the model. Okay. So, okay, we finished loading our model too. So let me just show that in action real quickly. Rerunning predictions with a randomly selected set of images, and our model is doing fairly well for this set that we picked. It got them all right. And then we can also just inline in our notebook, we can derive some metrics about our model. And I think I'll skip that just for lack of time. But of course, as you're doing the training, you can track all sorts of metrics and then graph them and view them how you like when you're done training or mid-training. One thing I'll talk about a little bit later, by the way, is using TensorBoard to monitor some of this stuff while model training is in progress. Okay, so now what I'm going to do is quickly see if there are any more questions on this notebook, and then switch gears and move to another one. Okay. So what I'm going to show next, so we've got this notebook that is doing model training. It's working well. We're pretty happy with our model, but we're not sure, whether or not maybe our model architecture is and the way we're configuring the training is giving us the best results that we could get. Maybe with our the transfer learning layers that we added, maybe we want those layers to be a different shape. Maybe we want more layers. Maybe our learning rate should be a little different. Maybe our training batch size could be different. There's all sorts of things that that you can tweak to potentially get better performing models. And so let's take a look at how we could tackle that next. And I'm going to do something kind of important here. I'm going to close down this kernel because I'm going to bring up another notebook. And this is the same same workspace. This is my workspace with GPU and enabled VM. And because the notebook I was just running had grabbed the GPU, I needed to shut down that kernel before I open this next notebook, which also wants to grab the GPU. Okay, so if you're following along, this is this notebook here in the featured workspace. So what is this notebook doing? This is our first look at how we could dip our toes into using the GCP Vertex AI services to help you do your model training and prototyping. And so there is a surface that's part of Vertex AI called Vizier, which is essentially a really flexible black box optimization service. And so you can use it for really anything that you would want to. And hyperparameter tuning all those parameters of a machine learning model that you might want to tweak, things like batch size and learning rate and number of layers, things like that. That all falls under this category of so-called hyperparameter tuning. But with Vizier, there's nothing that says you need to use it only for machine learning models. It's really flexible and useful. If you have other optimization tasks, you might want to consider using it as well. And so what we're going to do here is this is the point where we need to have this so-called native GCP project hooked up and ready to go. So you'll see that in the notebook. And so if you're following along, you would need to do that before you can run this notebook. Once we have done that, you'll see that our use of Vizier, this optimization service, is really lightweight and as part of our workflow here. Okay. So again, we require the same config as before. Now we require this native GCP project as well. And if you're running this example, because it's such a simple example, you actually shouldn't incur any Vizier charges on your native GCP project. It should be very low cost in that respect, and you should essentially just be incurring the Terra costs of running this notebook. All right, so the first thing that we're going to do is install the Vertex AI library. And I've already done this, so I won't run it again, but if you run this notebook yourself, typically after most installs, just to be on the safe side, it's a good idea to restart the kernel. And so that's what we're doing here. This is the SDK library for Vertex AI, and then restarting the kernel after it's installed. Then the next thing that's necessary to do here is, after you've set up your native GCP project, you'll need to set it in the notebook. So this is specific to my example. This is my connected native project, and so yours will be different. You'll need to change this when you run this example. All right. So we've set the project ID correctly. Do some imports. Again, finding the bucket. And again, loading the tissue data sets, which, because they're on the same persistent disk, this is very quick. Incidentally, when you're running this yourself, this is ignorable output. Essentially, it's just first time running this notebook in its new kernel. It's setting up the its GPU config here. Okay. Again, creating the data sets and doing a sanity check that we've got the images we expect. Okay, but here's where things get a little different. So remember, stepping back, the context is now we want to do some hyperparameter tuning with our model, and so we're going to package it up just a little bit differently. So I've defined a function to build the model, and here I'm creating a function that basically takes as parameters all of the things that I want to tune. In this case, batch size and learning rate. I'm going to try to tune, and some other config variables. So what I'm doing is I'm essentially creating a function that runs the does a model training run past given the hyperparameters that it wants to tune. Okay, so define this function. And now I'm going to define a Vizier study. And the details of this, again, are not important. If you want to do this yourself for one of your own models, you can just come back to this and kind of use it as a starting point. I'm doing some setup config. I'm creating a so-called study. So this is the I can't remember if I actually ran that. This is the place where when you configure the so-called study, this is the place where you configure what your hyperparameters are going to be and how you want to vary them when you do the hyperparameter search, what you want to what your objective metrics are. So what we're going to vary is batch size and learning rate for our model. Our objective metrics in this case are accuracy, which we want to maximize. And the algorithm in this case that we're going to use to do the search through the hyperparameter tuning space is random search. Okay, which is not the smartest search available from Vizier, but is cheap to run. Okay, so we're configuring the study. We're creating a Vizier client and instantiating the study with it. Then creating a function to evaluate the objective metric. So this is all a lot of setup to get something that is really nice and automated for you. And then finally, essentially configuring how many trials we want to run and how many suggestions or trial configs we want to get back each time we make a request to the client. So we're setting that to 1. We want to get back one suggestion each time. And in this case, I'm specifying run 5 trials and then stop. We won't let it run that long. And then we just kick them off. And so what's going to happen is this will run for quite a while if I would let it do so. And for each trial, we're doing some, we're training a model. We've specified to only do it for 2 epochs, which is a common approach where when you're doing hyperparameter tuning, you sort of don't do full training. You do enough to get a sense of how the different model variants are starting to pan out, and then you do full training on the top N. And so that's what we're doing here. We're starting a number of trials. So for this first trial, batch size is 32, learning rate is 0.01, and we can see it running. And the use of, as you can hopefully see, that the use of Vertex AI in this case is really lightweight. We're just using Vizier to give us suggestions about how to configure our model training. We're running the model and then we're reporting the results. And if I were to let this run for a lot longer, it would look something like this. Sorry, I actually clicked on the wrong thing here. Okay, so here is the result of a longer study, and this is I'm now working in the Google Cloud console. This is not necessary to do. You can get all this information right directly in your Terra notebook, but this is kind of a nice UI. So you can see that I ran a number of trials. Let me make this a little bit bigger. You can see the batch size and learning rate that were used for each trial and the resulting accuracy. So it's really kind of a nice service for doing lightweight, supporting of a hyperparameter tuning framework. Okay, I'm going to interrupt this as well. Okay, yeah, and you can view your results both both in the notebook inline. You can get information, and you can also go to the Google Cloud Console and see the information there. Okay. Let me see if anyone has any questions about that before I move on. Yeah, that's a very good question. The question is, when you interrupt, can you still access results run so far? Yeah, in fact, a given study, let me go back to the user interface, which shows this pretty well. A given study is actually considered ongoing until you explicitly stop it. And that's quite a nice model. All of these studies actually are that I've run over the course of several months are actually still active. And so let me show you part of the notebook that indicates how to do that. If you you can list the studies for a given project, and you can sort of reinstantiate a client with a given study, and you can just pick up right where you left off. If you didn't finish your search through the hyperparameter space, you can continue it. You can get information about the results of the trials run so far. GitHub repo link and downloaded PDF of slides is not a live link. Oh, sorry about that. I will fix that afterwards, and let me see if I can just bring up the. Okay, yeah, sorry, maybe I shouldn't try to fix it on the fly, but I will patch it up afterwards.
I'll be emailing
and
the
I think,
slide. Oh, sorry.
Oh, okay, yeah.
Yeah, we can send the right one.
I'll make a note of that. Yeah, we'll send the correction afterwards. So can I interrupt and then get the model run so far and use the model for predictions? Oh, so yeah, you could. You might have to be careful about how you wrote your function that's running a particular trial. Let me go back to the code for this to make this a little more concrete. Yeah, so here's the function that runs model training, and so it returns that model. But then in the particular way I wrote my code, the outer loop, kind of wipes out that model value with the next model, if that made sense. So if you carefully, but this code is up to you. The code that calls the trial. If you for your purposes, if you wrote this code so that each time you did another trial, you preserved the model, or saved it to disk so that you could reload it later, then you could do that, if that made sense. Yeah. So that's probably the more principled thing to do. The question is, can I add a step to save the model snapshot? Yeah. So that would be the most principled thing for both for hyperparameter tuning, checkpointing, and just regular checkpointing is all of the major machine learning platforms would have a way to periodically checkpoint and save your model, and so that you can always retrieve that later. So it's just a matter of when you're, this Vizier service is really very flexible and kind of leaves it up to you as to how you write the scaffolding around that, so just make sure that you do that so that you can do what you need to. Let's see. Is the purpose of performing a hyperparameter tuning search to find the best predictive accuracy only, or are there other parameters to assess too? That's a really good question. There are definitely other parameters to assess too, a whole bunch of them. So this was, I mean, it could be anything you want, of course. This was purposefully a really simple example. And so the your hyperparameters could be anything that you find useful, and your objective metrics, which can you can have multiple objectives, which I didn't show here, and you can both maximize or minimize any of your objectives. And so Vizier just leaves that up to you, whatever you would find useful to optimize. And typically, there would be more things that you would be interested in. So the question is the training blocked until the model is written, or is a separate thread in Vizier? So if I understand your question correctly, there's a you do you do a model training run, and then you tell Vizier what were your results. In this case, you're reporting accuracy, and so that is just a super simple API call. So there's nothing really to block of any significance, but it would wait until that call returned before it would loop again. However, you can also sort of batch your HP tuning runs as well. You can, Vizier is just giving you suggestions about, as it calls them, what's a set of hyperparameters to use for this next training run, and you can get multiple suggestions at once also. You can say, give me 5 suggestions at once. You can spin off 5 training jobs at once, and then report all the results, and then loop again. So it gives you a lot of flexibility. And then for metrics, this this can be again whatever you want to report. In this case, we are using from Keras its accuracy metric. And I can show that, I believe, up here. Yeah, it's the validation accuracy that we're just getting from the model, and we're returning that. But again, it could be whatever you wanted, and you just report that to Vizier. The Vizier's not doing anything smart aside from its search algorithm is smart, but in terms of processing, it just records what you give it and plots it for you and gives you the next set of suggestions in your study. Okay. All right. So I'm going to skip gears again, keeping an eye on the time. And I'm already sure that I won't have time to show everything that I thought that I might. Okay, so now let's kind of switch gears again and look at how we might use Vertex AI, Google Cloud Platform's Vertex AI for training and serving, so of a model. So here we're kind of moving beyond what we've been doing so far, which is just doing your training in a notebook. This is offloading your training or potentially serving for prediction to the Vertex AI service. So, you know, a question to think about is like, why might you, when would you even want to do that? Because what we just showed seemed like it was working pretty well. And for the most part, that's true. You know, if just, you know, single node, multiple GPU training is working well for you, then there's really no need to kind of move beyond what we were just showing. Because that's the most straightforward. It gives you the, you know, the most direct feedback if something goes wrong. You know, it's just kind of easier to use. And there's no reason that shouldn't be the default, and that you shouldn't just, you know, stick with it for as long as it works for you. However, when might you want to sort of do something different? One reason could be that you're training a very large model, and you want to do multiple node distributed training. You know, so you want to scale out more than just your notebook config can let you do. So that could be one reason. Another reason could be that you want to do, say you do want to set up a hyperparameter tuning job, but you want to distribute that. And that's actually a really good use case where you've got a large hyperparameter tuning space. You know, maybe the combinatorics of it, you know, say that you're going to be running, you know, whatever, 200 trials, something like that. You want to distribute that to a bunch of nodes at once and finish the trials more quickly. And so you also might find it just sort of easier and more straightforward sometimes to, especially if you have a long running job, to just, you know, sort of spawn that job off to a service. Your Terra notebook itself doesn't have to be high powered. It can be, you know, the very lightweight default notebook that you use just to kind of, you know, spawn off your job. You could potentially even close the Terra notebook while the job is running, and, you know, and then come back and work with the results. And so that can also be more straightforward if you don't want to worry about, you know, expensive notebook VMs or keeping track of whether or not something is idling out. Another reason that you might want to use Vertex AI is if you want to stand up an endpoint for model predictions. You know, so say you have a model that that you want to make it easy for your some of your colleagues or some of your teammates to use, and so you may want to deploy that model online in a way that that other people can to a so-called endpoint in a way that other people can hit that endpoint and get model predictions. And that can be useful. You know, obviously you would be thinking about that if you were trying to, you know, productionize something, but it can also be useful just for, you know, making your work more accessible to a larger number of people, even if you're not actually productionizing. Okay, so let's look at take a quick look at how that works to set up. So now we're what I've done is I've switched to just in case you're very eagle-eyed about the workspace setup, I've now switched to a different workspace. And the reason is that it's running a different cloud environment. And in this case, because Vertex AI is going to be doing all the work, I don't need a GPU, and I just need one CPU. And so this workspace environment is a lot cheaper than the other one. And my costs instead are going to be incurred by the native GCP project where I'm doing the training. And of course, how much that costs depends on how long the training runs and you know, what size machines you use to do the training and a lot of things. So this is the same same little example that we were looking at before, the tissue sample classification example. And so again, I've already done this, but the first thing you would do is install the Vertex AI SDK and restart the kernel. Make sure that the import is grabbed correctly by the kernel. Okay. So I'm doing some setup, and here I'm doing some useful tricks that if you're not familiar, you might want to take a look at, to let you grab information about the workspace. And so I won't spend too much time on this, but I'm accessing this nice feature. You're able to set and grab workspace attributes to get the name of a package that we'll use. And you can see that I successfully grabbed it there. Okay, next thing I'm doing, and so this, I won't have time to go into in detail here, but this is the place where you really have to have done a lot of, fairly substantial setup of this native GCP project before you can proceed. And I need to, there's the name of my project. I needed to create a service account with some certain permissions, and create a bucket in that native GCP project that I'm going to use. And I also did some optional setting up of a TensorBoard instance. And all of that is explained in this notebook. If you go through this process and have any issues or any confusions with this notebook, please do let me know. Okay. All right, so I'm doing some config, checking that everything's set up properly. Here's the service account for my native GCP project. Here's the bucket that I'm going to use. I'm doing some copying of a Python package to my workspace. Sorry, from the workspace bucket to the native GCP project. And now I'm ready to go. I skipped over all of that stuff kind of quickly because that's the nuts and bolts that if you're going to come back and do this for real, you can stare at it more closely. Okay, so now I'm going to initialize the Vertex AI SDK, which I installed and imported with information from the native GCP project. The next thing I'm going to do is something kind of useful for any of your Terra machine learning exploration or data science exploration. And so this is a little trick that might be of interest. Vertex AI has a so-called experiment API that lets you just track what you're doing and essentially log information about the tests and experiments that you're running. And it's really kind of useful. So I'm going to create I'll show you what that looks like in a second. I'm going to create a new experiment just for tracking what I'm doing here. I'm going to create a training script. I won't go through the details of that here, but it's essentially much like the code that we were looking at just a little bit ago in the previous notebook. It uses a Keras model for training. So we created a Python script that sort of packages that up. We're indicating what VM images we want to use for training and serving. Defining some information about the arguments that we're going to pass to the training job. So this is exactly the kind of thing that you might want to record as you're doing experiment tracking, which we'll see in a second. And then we'll create and run the training job. Okay, so here I'm going to log some information to this experiments API. I'm going to, as they say, it start a run, and I'm going to gather some information about the parameters of that training run, and I'm going to log them to the experiments API. So that's what I'm doing here. And just for fun, we can see what have we logged so far. So we're tracking a particular run, and we've logged a bunch of information about the parameters and where we're saving the results and things like that. That is available. This information is available later, either programmatically or also in the cloud console. And so you can see a little of that happening here. You can see the experiment that I just created, and you can see that the information that I've logged to it so far. Okay, so now I'm just going to define and submit this training job to Vertex AI. And of course, there's a lot of stuff I'm skipping over kind of quickly. But again, the details are here if you want to come back and try this yourself. Okay, so I've defined the job. Now I'm going to run the job. Let me kick it off. And it will give some links about the job as it runs. So let me just show you what that looks like. Again, back to the Julia child model. This is an already run training job. And so you'll get some information like this about the job as it's running. So since you have, just to kind of reiterate that what we're doing here, the context is that we're doing essentially the same training as we showed before, but now we're running it on Google Cloud Platform on the Vertex AI training service. And so there's nothing really of interest going on in the notebook now, except for we're going to get periodic status reports. We can kill the notebook if we want, and it will not kill the job. The job will keep running. And so the way to get detailed information about the job then is from the cloud console. And so you can, I'll go to the logs for a previously run job. It's kind of hard to see at this font size. Let's see if I can. Let me make this a little smaller for a second. You can kind of see, I just jumped midway into the log. So you can kind of see it's like midway through one of its training epochs. Essentially, you see everything in these logs that you would see directly in the notebook if you were doing in notebook training. And so that's the model now. The job runs, you can kill the notebook if you like and come back to it. And then finally, when it's done running, you can get results and work with the model further if you like. And so the cell here, if you run this yourself, the cell here is important because it preserves some information that you'll need if your notebook loses context or if you explicitly kill it and then come back to working with it later. Okay, so the job continues to run. After training has finished, suppose you decide you want to use Vertex AI to also serve your model. And something that I should have been a little more clear about up front is that with Vertex AI, it's kind of a mix and match model that you can do. So you can use Vertex AI just to train a model if you like to, And then you can take that model and you can do, you can download it and you can do whatever else you want with it. Or conversely, you can train your model elsewhere. And then when you're done, you can upload it to Vertex AI and use it for serving. So really you can mix and match. You can use it, Vertex AI, just for training, just for serving, or you can use it for both. So with this example, we're using it for both. Once the model is finished training, it does an additional step that's called model upload. It uploads it to a particular named place. And then you can create a so-called endpoint for prediction. You can essentially deploy a given model to a Vertex AI endpoint and then hit that endpoint with prediction requests. And so I'm not going to take the time to do all of that, but let me just show you sort of what the overview of how that would work. So if assuming that you've trained your model, you want to deploy it to an endpoint, what you would first need to do is do a little bit of definition, and you can do this in various ways, incidentally. You can deploy your model programmatically, or you can just do it in the Cloud Console. But you need to do a little bit of definition of what kind of traffic splitting you want on your endpoint. And, in other words, do you want all traffic to go to this new model that you're deploying, or do you want to split it, which is really good for A/B testing. And you need to define some information about the compute power that you want to use for your endpoint and how it scales. So these endpoints can auto scale, which are useful if you have a lot of traffic, going to your model for prediction, and you can cap the min and max parameters of that scale. Okay. And then keeping an eye on the clock. I'm sort of skipping through a lot of this that you could come back to and look at more detail later. Once you've done all that, you can run a call just from your notebook to deploy a model to an endpoint. Once that model is deployed, you can use it for prediction. So skipping ahead to that stage, I've got an already created endpoint that I'm just going to send a request to, just to show that it kind of works the same as what we saw in the other notebook. Okay. So I grabbed an image, I've done a little bit of munging of the image, and I've sent it to the endpoint where my model is deployed. And then I can look at the prediction results, which look like this. So we had the image was non-atastic, and the prediction was correct. Okay. All right. So since we're running a little short on time, I'm going to stop there and see if anyone has any questions about that notebook. And just sort of the basics of interacting with Vertex AI as well. Okay, no questions. So what I think I will do then is I'm going to, let me go back to the agenda for a little bit. Due to lack of time, I'm going to skip the BQML example. However, it is, let me give it a little plug for it because it's really cool. Oh, yes. some questions. Yeah, distribute hyperparameter tuning jobs. Yeah, that's a great use case. And then I'm not sure I understand the question about the Vertex AI cost. Oh, yeah, Terra versus GCP. So essentially, what you're using, your Terra workspace also is using GCP under the hood, and the costs are the same, regardless, of what project they're associated with. So there's like no difference in the charging, depending on whether you're using a so-called native GCP project versus Terra, and so the costs, so there's no difference in the charging. There's no surprises, but in terms of the breakdown, anytime, like with the example I just showed, anytime you go off to the Vertex AI services, you're incurring those charges, and at the same time, while your Terra notebook runs, while your cloud environment runs, you're incurring those charges. And so, sort of the most easy to understand model would be like, once you kick off a training job, you can just shut down. You can just pause your Terra VM, so you know that you are having no Terra charges, like while you're waiting for the training to finish running, and then you can fire back up your Terra VM once that does finish, if that helped. Yeah, so in this case, the question is, so the Terra is CPU and Vertex is GPU. Yeah, and in this case, we could create a lightweight Terra CPU only environment, because we don't need the GPUs, and then we're configuring our Vertex training with GPUs. And again, the charge breakdown is the same, so it's just kind of like where you want to do your work and what's most convenient for you. Okay. All right. So I actually wanted to leave just a few minutes to sort of hear from you guys about what you hope to use machine learning for. But before I do that, going back to the agenda, let me just put in a little bit of a plug. So I'm not going to have time to get to this notebook, the BQML notebook, which even more confusingly is not part of the featured workspace at the moment. So you'll need to use this link, and we'll include it. Sorry, that's not the right link. You'll need to use this link, which is a GitHub just currently. We'll include that link again in the follow-up email that we send. But let me just give a little bit of a plug for BQML, because for those of you who use BigQuery and are working with data sets in BigQuery, which might be at least a subset of you, this is a really cool thing. What it essentially lets you do is automatically build models, drawing from a whole range of supported model types on your data, on your BigQuery data, without having to define the models yourself, just using SQL queries, and then to inspect those models and to use them for predictions and for explanations. It's just really easy to use and really nice. And so the example notebook, which I won't have time to go through, shows one example of that, and I've included more examples in the slides. And you can see here from this graphic that I posted in, although the font is a little teeny, that there's just a whole range of supported model types. And one particularly powerful one that's included in this set of model types is AutoML tabular classifier. The GCP has a suite of AutoML services where you can bring your own data, and it will using a set of sophisticated techniques will build a model, a very high performing model for you. One of those suite of AutoML services is AutoML Tabular, and BQML supports that. So if you have really rich tabular data, and you want to try experimenting with automatically building models that make predictions on that data, this is a really good place to start. Yeah, so question about data ingress, how to use my own data. So that question would be answered differently depending on what kind of machine learning framework you were using, but just to be a little more concrete for the first example I showed you, the place where that would happen, if you were using TensorFlow and Keras, like this example is using, then there's a whole module in TensorFlow called TensorFlow.data that is sort of being used by the TensorFlow hub code that's running here. So long story short, yeah, so you can you essentially need to build your own data sets and data pipeline from your own data using, in the case of TensorFlow, the TensorFlow.data module. And from there on, everything sort of works the same because that gives you a very standardized input to your model training. Can I get data from my Google Drive? I think for the answer is sort of. I think you'll have to convert it to or migrate it to a GCS bucket, or perhaps local data if it's not too big to be able to use it. So I think you'll have to port it probably from Google Drive before you can use it. Right, a question about VM security firewalls. Yeah, so that is too complex to answer properly right here, but the answer is yes. You can button this stuff down as much as you want. Google Cloud Platform has a lot of mechanisms for doing that. So, for example, the endpoint I was playing with, the model prediction endpoint that I was showing earlier, the way I had that configured, I'm the only one who could access it, and but I would be able to open it up to more people if I wanted to. And there's all sorts of ways that you can button down your network as well. I know that was not a very complete answer, but basically GCP does have all the mechanisms that you need to button things down as you like. Okay. So I will stop there. We are, I know we're almost out of time, and I didn't leave as much time as I meant to originally for sort of hearing about your own use cases. So in the remaining 2 minutes, does anyone have anything they'd like to, other questions, or maybe briefly describing what you're interested in doing with machine learning on Terra?
Anyone brave enough to share in the chat what their use case might be? Oh, great.
Oh, very interesting. Yeah. maybe we could, when we do the survey, Elizabeth, maybe we could have an open field for anyone who wants to share. I'm very interested to hear.
That's a great idea.
Oh, predictions using all of us. Yeah, all of us is a great fit, incidentally, with BQML, although it's the data is quite buttoned down. Any quick tips on how the mindset needs to change moving from traditional HPC to cloud? Maybe nothing quick enough. It is a bit of a different mindset. So you sort of move to it's a bit more of a serverless mindset, isn't it? You know, where you just use things when you need them and pay for them only while you're using them, perhaps. Yeah, that probably was not a very satisfactory answer. Useful to think about that a little bit more. And someone's working on NLP. That's great. Okay. Well, I think we're right out of time. Thank you so much, everyone, and for all your good questions. Another use case related to image classification. That's very interesting. Yeah, I hope these examples can kind of get those of you doing that kind of thing jump-started a little. I'll be interested to hear from you. Okay, so I will wrap up. Please do feel free to email me if you have any follow-up questions, and I'm happy to obviously see GitHub issues filed too. But you know, do feel free to ping me if you have any feedback or have any questions.
Thank you, Amy. Thank you so much.
Thanks so much.
Yeah, thank you for coming out and doing this presentation. I just wanted to mention that we will be following up with an email with a link to the recording, so you all can try the workspace after the workshop, as well as links to the updated slides. And I definitely wanted to put a plug in for the next machine learning webinar, which will be October 11th. The registration for that will be going out soon. That's going to be Machine Learning for Health by Sam Friedman. It will focus on survival analysis using the Machine Learning for Health framework. And thank you again, Amy, and thanks to all of you who came out today and for your wonderful questions.
Thanks, everyone.